Hello, Einstein. Are you ready to attack the Monty Hall problem? Great, let's get going. But before we start, let me just emphasize that this is not a problem you will see on the exam. It is a classic probability problem that should be fun for smart students like yourselves, and hopefully you'll enjoy going through it. You may have seen this problem in a movie, 21, where the MIT kids went to Vegas to play blackjack. Fun movie, terrible explanation of the answer to the problem, or certainly lacking in detail. So, let's look at the Monty Hall problem in more detail. It's named after Monty Hall, who is a famous game show host who ran a game show that is much like the following. He would have 3 doors or curtains, and behind one of the curtains would be a new automobile. Behind the other 2 curtains would be a goat. Bah! Not fun. So obviously the contestant would try and guess which one is the car. A typical contestant might guess, the car is behind curtain number 1. And then Monty Hall would do the following. He would open up one of the other curtains, only to reveal it's not the car. In fact, it's a goat. Like my picture of a goat? It's fantastic, isn't it? So that would leave the contestant with the following choice. Do I keep door number 1, my selection, or do I switch to the other door that's still closed, or the other curtain in this case, curtain number 2? This is a conditional probability problem, which tends to be counterintuitive and not follow your common sense. In fact, conditional probability problems often are the exact opposite of what your common sense tells you. In this case, a typical student or contestant might say, well, I've got a 50-50 choice now between 1 and 2. I could switch, I could not switch, it doesn't really matter. But, like most conditional probability problems, your intuition will steer you wrong. Most people understand the car could be behind any of the 3 curtains shown, which are our 3 scenarios laid out here. The car is behind 1, the car is behind 2, and the car is behind 3. The probability of success is 1/3. There's 1 car and 3 curtains to choose from. So far, so good. That part seems simple enough to most people. It's when we add conditions to the problem that things begin to get a little tricky. And the first condition is, of course, that the contestant must select a curtain. We'll say contestant selects curtain 1. And take note, because all the curtains look the same to the contestant, it doesn't matter if we call his original choice curtain 1, curtain 2, or curtain 3. If you run the same scenarios for each of those, you'll come up with essentially the same result. The real condition that comes into play that changes the problem is when Monty Hall reacts to the contestant's choice of curtain. Monty Hall must open a curtain that's not the contestant's curtain, otherwise the game would pretty much be over at that point. And Monty Hall must open a curtain that's not the car, otherwise again, the game would pretty much be over at that point. Let's take a look at each of our 3 scenarios given the contestant's first choice. If we're in scenario 1, where the car is behind curtain 1, that means the contestant was correct. And Monty Hall would have to open up either curtain 2 or 3, neither of which has a car. They both have goats behind them. So Monty Hall has a choice of what curtain to open up there. And the best course of action in this scenario is to stay put, not to switch. But of course, the contestant doesn't know that. It could be scenario 2, where the car is behind curtain 2. In this case, the contestant would be incorrect, and Monty Hall would have to open up curtain number 3, because curtain 1 is the contestant's choice, curtain 2 is where the car is, so that only leaves Monty Hall with the choice of opening up 3 and showing the goat. Now, the contestant would be better off switching from 1 to 2, the correct curtain. In scenario 3, the car is behind curtain number 3. The contestant's choice of 1 was again wrong, and in this case, Monty Hall has no choice but to open up curtain 2. Curtain 1 again is the contestant's choice. He can't open it up. Curtain 3 has the car, so he can't open that. Monty Hall must open up curtain 2, which leaves the contestant with choice of 1 that he chose, or the option to switch to the car on curtain number 3. And of course, the best choice for the contestant at that point is to switch to curtain number 3, where he finds the car. Now recall, the contestant did not know what the best course of action is in scenario 1 or scenario 2, should he stay or switch, because he wasn't privy to where the car actually was. But the contestant does know there were 3 scenarios. And in only one of those 3 scenarios does the contestant find the car by staying. And that's the scenario where the contestant guessed correctly in the first place. But 2 out of the 3 scenarios, the contestant is better off by switching. So the probability of switching and finding the car, given Monty Hall's actions and what curtain Monty opened up, is 2/3. Or another way of looking at it is, when the contestant guesses incorrectly, Monty Hall must open up the only other curtain with a goat, which absolute certainty leaves the curtain with the car as the other curtain. So with certainty, in 2 out of the 3 cases, the contestant is better off by switching. And only in the one possible scenario where he guessed correctly in the first place is the contestant better off staying. As the movie says, that extra 1/3 probability accrues right to the contestant by switching. Thank you very much for that extra 33.33333%. I'll take it and double my chances. Hopefully you understand the line in the movie a bit better now, but please don't go running off to Vegas anytime soon. Thanks for your help, Einstein. Have a great day.